In an earlier film, we looked at whether it makes sense for Wight Salads to invest in robotics to lower labour costs. Now we return to Wight Salads with a different sort of problem, one that can be solved using linear equations. Hugh and his partners grow tomatoes exclusively. Although they grow many varieties, tomatoes are all that they produce for leading supermarket chains in the UK.
Certainly in the UK there's a very good market for very high quality, very specialist product. It is a niche market, and we grow roughly 150 different varieties. We're trialling all the time. Every year we're trialling new varieties in terms of development, and we're moving further and further away year on year from the standard type of product.
So our tomato grower has been focusing entirely on the production of tomatoes. Is it now the right time to diversify into other related lines? Would it make sense for him to give up some tomato production and to begin to produce something else? How do we come to the correct decision as to whether to diversify or not? Well, linear programming is a very powerful technique to help us come to the most sensible conclusion. Hugh is thinking about a small-scale trial to test the viability of diversifying into lettuces. And he's thinking about using a relatively small greenhouse for the purposes of the experiment.
Let's work with the following assumptions. The amount of labour required each day per box of lettuce is 15 minutes. For tomatoes, the daily labour is 10 minutes a box. For this trial, he wishes to use only one 7-hour day of labour. Let's also assume that the greenhouse space set aside for the trial can produce up to 50 boxes of lettuce. Tomato plants being larger will yield a third as many boxes in the same greenhouse space. He's not confident of selling the lettuces in large quantities, so he's decided on a maximum of 10 boxes. Since he can always sell the extra tomatoes, he wishes to grow at least 12 boxes of them. He could get £6.25 for each box of lettuces and £20 for each box of tomatoes. Actually, Hugh doesn't need to conduct the experiment at all. By the use of linear programming, we can calculate what he should do.